a Portland Community College mathematics telecourse. A course in arithmetic review produced at Portland Community College. Again, this lesson will presume that basic facts such as these that you do know. In short, your division tables, which is nothing more than a reverse multiplication table. If you do not know these, then consult with a specialist at your school. Let's recall for a moment that division can be shown in several different ways. This is, of course, the division symbol. So this reads 16 divided by 2 is 8. So it's important to realize that this symbol does not mean divide, it means divided by. This can be read as 16 divided by 2, or if you wish, 2 into 16 goes 8 times. The fraction bar also indicates the phrase divided by. So 16 divided by 2 is 8. This factor will become very important to us when we get to decimals and fractions, that you remember that this bar means divided by, not divide, but divided by. That simple little fact will make some problems very simple for you later. But be prepared to change from one notation to another or to another as convenience strikes us in future problems. Also, let's note our ever-increasing vocabulary. The number that's doing the dividing we call the divisor. The number that's being divided into we call the dividend. The results of the division we call the quotient. So in fractional form, the top is being divided into, hence its dividend. The bottom is what's dividing into it, that's called divisor, and the answer we call quotient. Now also we remember that this bar is a fraction bar, where you might recall the top is a numerator and the bottom is a denominator. This will be important for future problems to realize that a division problem and a fraction problem are indeed the same problem, simply looked at differently. Let's also recall that a division is an implied multiplication. To ask 24 divided by 8 is what is the same thing as saying what times 8 is 24. Or if you're dividing with this standard notation, if we say that 8 goes into 24, and of course we know it goes in 3 times, remember that the check is to ask, will this quotient times this divisor equal this dividend? That fact, simple as it is, will help us in the future. Let's also review two very simple but often misunderstood facts. Division by 0 is not possible. See here, I'm dividing by 0. And the reason being is no matter what number you put here, any number in the world, that number times 0 is equal to 0 and never 4. So I can never find a number times 0 that will be equal to anything other than 0. So division by 0 is not possible. However, division into 0 is possible, because of course in this case 0 times 4 is 0, and it checks. See how very important these two very small words are. Division by and division into are two entirely different concepts. Here I'm dividing by the 0. Here I'm dividing into a 0. And so be very clear in your mind the difference between dividing by something and dividing into something. Let's run through one division process very quickly. And if this is too fast, then we suggest that you read your lesson very carefully and possibly seek some special help. Now, when the divisor is quite large, so that we don't have to think 264, round this to the nearest front digit. So that's 5 or more. So let's think of this as 300. Now you think 300 goes into 8 0 times. Don't say it won't go, it will. It goes in 0 times. Then 300 goes into 80 0 times. 300 into 800, about twice. But the number is actually a little bit less than 300, 200 something or other, so let's try a 3. If that is too high, we'll have to come back and try another. This shows one point, that when we're dividing, we're really doing an estimated multiplication, and now we'll check by actually multiplying. 3 times 4 is 12, 18, 19, 6, and 7. If this seems to be just less than this, then this was a good estimate. But we subtract to be sure. This is less than that, so that's the appropriate amount. We brought down the next digit. 264, or about 300, goes into there 0 times. I'm going to emphasize that. It goes in 0 times. Do not say it won't go in. It always goes in, at least 0. Now, bringing down the next digit, and we'll cover up these two digits and these and think that I have 2, almost 3, going into 13. 3 goes into 13 only 4, 2 goes into 13 about 6 times, so let's try the 5. Now, quite frequently this trial is wrong. Don't be afraid to adjust and try another. Now, trying this, 5 times 4 is 20, carry the 2, 32, carry the 3, 10, 13, and subtracting. We're at the end of our whole number. This is less than this, so we divided the proper amount of times. So at this stage of our reviewing, let's just leave the remainder as a remainder. Now, had this come out 0, then that means that goes into this evenly. Now, of course, you might recall that sometimes we can put in a decimal point, keep on going, or express our remainder as a fraction. We'll delay reviewing that until a later chapter. 2 points to remember here is that a number always goes into another number at least 0 times. It's just that these front zeros in whole numbers are not necessary. They don't add to or delete from the value. But zeros in between changes the number. Without that, that's 35, which certainly is not the same thing as 305. Please note this. This is a most common mistake. Now, to check that we are correct, remember that the quotient times the divisor should be equal to this. But we have a remainder left over we must take care of. So to form the check of a division problem, you will multiply these two. And to the product, which certainly is not equal to that, we add the remainder. 71. And ask if the answer is equal to the dividend. And if it is, you were correct. That's very fast. You might need some additional help on that. But at least this very quickly reviews the division process. There are very many other division processes. This one is the most standard. Perhaps your teacher will show you another, or perhaps you in your past learned a different process. There are some techniques where the digits of the answer are written down the side rather than above. They're all perfectly good. It's just a matter of what was one trained in. This is the one that most adults recall from their childhood. Now let's see what division offers us by way of getting ready for algebra. Here we have an equation that reads 35 times some number is 1715. What was that number? The fact we need to recall here is that I'm increasing this by a factor of 35. So if 35 times your money is something, to ask what did you have originally, we would have to take 1/35 of what you have after multiplying. Or in short, division undoes multiplication. And you're back where you started from. And of course, if I divide your total amount, whatever it is, by 35, I have to divide that amount by 35. However, I write it. The key point to remember is that division undid that multiplication. And of course, since these are the same number, I do the same thing to the number over here. In algebra, we will state this way. Both sides of an equation may be divided by the same amount. Now, of course, algebra will look at this a little bit more technically and a little bit more precisely. But this begins to move us into solving simple equations very quickly. And of course, the result of that division is 49, which is the value of the b. Again, division undoes that multiplication and gets you back to where you were prior to that, which is the value of the variable. Now, what happens if we have an equation in which the variable is only being divided by another? And here the key idea is that multiplication undoes the division. So multiplying something by 34 undoes it having been divided by 34. And of course, since this side was the same number, I must multiply it by 34 as well. So this says that t is 18 times 34, which is 612, the value of t. Division is undone by multiplication. Now, your friends in algebra will probably remember this rule as both sides of an equation may be multiplied by the same amount. Now, when you do get into algebra, be prepared to be a little bit more technical and detailed than this. But this at least gets you moving into algebra a little bit more comfortably, and we hope with a little bit less fear. Let's conclude this short lesson by working a couple of problems together in great detail. And while doing so, let me point out some of the pitfalls of the average inexperienced student so that perhaps you can avoid those. First, notice on my work paper, I'm going to turn the paper sideways so that my lines are going up and down to set up my problem. Then remember, as we write it this way, this reads 312,067 divided by 763. So this is the number being divided into, or dividend. This is the number dividing by, or the divisor. So writing our dividend, 312067, one digit in each column of my paper helps me keep my workspace straight and orderly. Then my divisor on the outside, so that we now can keep my columns in an absolutely straight line and not get lost as to where we were at any moment. Then a trick used by many is to simply cover up all but the front digit. So I had to cover up 2 here, so I want to cover up 2 here. So if I cover up 2 there, there's nothing to go into. 2 there, 7 won't go into 3. Then move over to the next 2. 7 will divide into the 31. So looking at the covered up portion, the end digit right here is where the first digit of my quotient or answer will go. Now, there are various schemes for doing this, but this is one of the most convenient for keeping track of where you are. Then you think, okay, if I cover up these 2 and these 2, 7 goes into 31 about 4 times. Remembering now that actually this is closer to 8. So if I try the estimated 4, I am prepared to back off and make it larger or smaller. This is the first thing for a beginner to realize, that this estimation, and this is nothing more than an estimation, might not work. So do be prepared to back off, erase it, and try another. So to try this, we multiply this times this to see how close to this it really is. Remember, the quotient times the divisor must be equal to the dividend. So 4 times 3 is 12, carry the 1. 4 6s is 24, 1 is 25, carry the 2. 4 7s is 28, 29, 30. And to know that this is proper is to first have this be able to subtract from this, which it can, since it is smaller. And my subtraction must yield a result less than this. So 2 from 10 is 8. 5 from 11 is 6. 0 from 0 is 0. So this is smaller than this. Bring down the next digit. And see, by keeping your columns lined up, that means I'm working over to here now, and furthermore, the next digit of my answer must go here. So covering up 2 again, covering up 2. Do not say 7 will not go into 6. It's very important that you realize 7 will go into 6 0 times. Then, of course, 0 times this is 0, and this subtract 0 is the same number. So rather than to go through all of that, I'll simply bring down the next digit. Now covering up the N2, covering up the N2, and thinking 7 goes into 68 about 9 times. 9 might be too big because this actually is larger than 7. It's almost close to 8. But we will try the 9. 3 9s is 27, carry the 2. 6 9s is 54, 55, 56, carry the 5. 7 9s is 63, and 5 is 68. Subtract, and we get 0 remainder, which tells me that this went into here evenly. Now the check would be, will this times this be equal to my dividend? And it is. The most common mistake students make at this point is to leave this 0 out. Do not do that. And perhaps the reason they left a 0 out is they began by thinking that 700 won't go into 3, it won't go into 31, so we didn't write anything up here. Actually, 763 does go into 3 0 times. It does go into 31 0 times. It does go into 312 0 times. It's just that the zeros at the front of whole numbers are not necessary, so we don't bother writing them. But the 0 placeholders in between digits make all the difference in the world. Certainly if this was money, you would never confuse this with this. So if you get a number where you think that this won't go into this, always remind yourself it will go in. it will go in at least 0 times, and that 0 must be recorded. Be very cautious of that. It's a very common slip. Let's do one more problem. As we try to estimate how many times 63 will go into this number, again we cover up 1. 6 will not go into, 6 goes into nothing, 0, into 3, 0, and finally 6 is going to go into 36. We think about 6 times. But remember, the number we're going to put down there is really an estimate. It may be too large or too small. Let me deliberately select a number which is too small just to make a point. I'm going to select 4, which is obviously too small. So you might think, well, if I take this times this and find it's too small, I'm going to have to erase that and try something larger. Not necessarily small. So, as long as we're estimating this number to begin with, the safest estimate is the smaller estimate. Watch and you'll see why. Multiplying this out, we get 12, carry the 1, 24, 25. Subtract, and we have 3, 1, 1. Since this is larger than this, that means this would have gone into this more than 4 times, but rather than erasing this and starting over, let's just now work between this and what I currently have after I subtracted, and ask 63 will go into this how many more times? And we can see only 1. But note we're still in this column right here, so I'm going to adjust that 4 by 1. And I will write the adjustment up above. So 1 times 63 is 63. Subtract. This is smaller than this, so now I am okay. So I went in actually not 4 times, but 4 plus 1 more, or if you wish, 5 times. Okay, bringing my next digit down. Here again, if I wasn't quite sure, 6 goes into here. It looks like 6 eighths is 48, so it looks like it'll be 8 times. But this actually makes it larger than 6, so 8 might be too much. So if I'm not sure, I will estimate by 7. 3 sevens is 21, carry the 2. 7 6 is 42, 44. Subtract. 3, 6. We can see now this would have gone into here, which is here, 1 more. 163 is 63. It went in evenly, and this 7 was adjusted by 1 to give me 8, so my quotient is 58. So if you're not quite sure about how many times this will go into here, and you're estimating, estimate low, take your difference down here, ask will it still go in more, and if it will, adjust this by however much more you think you'll need, multiply that, subtract, see if everything is okay now, and keep right on going. That saves you a lot of time over erasing something and reguessing and remultiplying. If you can remember that, sometimes that will save you a bit of time and frustration. And of course, currently much of our work will also be done on your calculator, so it's well for you to get used to using it. Remember the number you're dividing into. Your dividend is the first one entered, so 3, 6, 5, 4. Then find your division key, which on this calculator is right here, and push that, which doesn't show here. Then enter your divisor, 63, then your equal, and sure enough, there's my 58. Now some calculators, like this larger one, will actually show your work while you're entering it. See, 3, 6, 5, 4. Here's my number, divided by, see it keeps my division, 63. So my whole problem is on the calculator, and now if I push the equal, it gives me my answer. Some calculators even have the property that this one does, that if I push the playback, it'll go back to the original problem just in case I made an error. I can find it and correct it by moving a cursor. But know that every calculator is different. So always find the most inexpensive calculator that will serve your purposes, and by all means do not forget to keep your instructions manual. Many people throw that away. Keep it for about as long as you will own the calculator, because each calculator will be different and you cannot always expect your instructor to show you how it operates, because every student might have a different calculator. One last look at simple algebraic equations. This reads 48 times some number called k is 4416. To solve the equation, we're trying to isolate the variable so that the sentence itself will tell us what k is. See, k is something. Remember, it's not the 48 we're trying to undo. We ask primarily what is the 48 doing to the k, and it's multiplying. So the question is, what operation undoes multiplication? And you undo multiplying by dividing. So this tells me to do this irregardless of what this number is. Then as a secondary factor, we decide it is 48 that's doing the multiplying, so we undo multiplying by 48 by dividing by 48. Then the algebraic law says if I divide the number of this side by 48, I must divide the number this side represents by 48 as well. So division undoes multiplication. The 48s in a sense are incidental. So please concentrate on the operations, and you find that moving into algebra will be quite easy if you do so. Now this reads k, which is all that's left, is 4416 divided by 48. And on our calculator, if we wish, 4416 divided by 48 is 92. And to check it, our original problem said that 48 times k, which we're claiming now is 92, should be 4416. And if we multiply this, 92 times 48 equals, indeed I do get my 4416 back. So you see, we can use division as an excuse to not only lubricate our computational skills, but to begin to become comfortable at reading at first simple algebraic equations and what we mean by solving simple algebraic equations, so that later we have a better background for going into the more complicated situations. So my suggestion in this lesson is do your divisions first by longhand, and then, if you wish, check it on the calculator. But be sure that you can do it before you entrust it to a mechanical or electronic device. That's it. This is your host, Bob Fennell, saying good luck until our next lesson.